Hello and welcome to the Armin Show podcast. Science, people, creativity, learning more. We are always expanding across YouTube, Spotify, all the platforms. Subscribe if you haven't. Comment, leave a like. Support the show as it continues to grow. And we have the coolest guests out there. On this episode here, we have an expert in the field of artificial intelligence and more. And with his co-author, Eric Niller, Dr. Rama Chellappa, author of Can We Trust AI? Joins on this episode of the show. Dr. Chellappa, welcome to the show.
Good morning, Armin. Thank you very much for having me on your show. Looking forward to our conversation.
I'm looking forward to it as well. Now, as far as some background here, you are a pioneering researcher and inventor in artificial intelligence, computer vision, and machine learning. You're a professor in electrical, computer, and biomedical engineering, and a member of Johns Hopkins Center for Imaging Science, Center for Language and Speech Processing, and the Malone Center for Engineering in Healthcare. A wide variety of qualifications. Can you tell us how you got to the current moment that you are in? Why are you where you currently are?
Yeah, I came to the United States in 1977 to do a PhD in electrical engineering at Purdue University, and after I graduated in 81, I went to University of Southern California. I was an assistant professor till 91, and then I moved to University of Maryland, College Park as a professor, distinguished university professor till 2020. And so this is my third rodeo. I'm in Johns Hopkins University now. I moved in August 2020 with the goal of exploring the impact of AI and machine learning on medicine, healthcare, and engineering in general. So I direct a lab known as Artificial Intelligence for Engineering and Medicine. It's called AIM, and we have about 20 doctoral students, 3 postdoctoral researchers, and keeping ourselves busy with developing some foundational research as well as applications of artificial intelligence in engineering and medicine.
This is wonderful. Now, why the specific interest in going into artificial intelligence? What value did you see in the category early on? And was it a message to you that it will be valuable, or did you see it on your own choosing?
Oh, yeah. I think when I went to Purdue in 77, I went there to study pattern recognition because Purdue University is considered to be one of the top universities in that field. We had several pioneers. And then in those days, artificial intelligence was also a field that was developing. It kind of officially started in 1956. And it went through its first, decade of a lot of progress and expectations and so on. So I think, as an engineer, as a technologist, you're always thinking of building, systems that can reason like humans, and make decisions based on domain knowledge and data and so forth. So this is something that most people who are in computer vision and pattern recognition are interested in. And so that is what piqued my interest. And of course, as I say in the book, in 1969, I was about 15 years old and was just truly impressed that we were able to send people and drop them on the moon and pick them up and bring them home. So technology has always been something that's of much interest to me. And you have all these interesting robots and talking cars and flying cars and things like that, as you see in exactly. So so artificial intelligence is of interest from many directions, but the general interest is that designing systems that can reason not exactly like human. On the flight yesterday, I again saw the movie Imitation Game. And there is a very nice place where Alan Turing, the actor who acts like Alan Turing, says, just because machines don't think like us, it doesn't mean they're not thinking. I mean, that's, I don't know, somebody wrote that obviously in the movie. And I was thinking about it. That's true, So it has a lot of interesting aspects to it. So, yeah, that's why I got into this field.
How would you describe the current state of artificial intelligence right now as compared with 20 years ago? What are some of the largest changes in the field in the last decade or two?
Yeah, that's a great question. 20 years ago, when we thought of AI, right from the beginning, we were big on domain knowledge. For example, if you want to build an artificial intelligence to play chess with you, it should know what the legal moves are. It can't just randomly, throw a piece here, throw a piece there, right? So it uses domain knowledge. So that's where the emphasis was. Modeling causal relationships among various things that we see, and so on. Since 2012, it has taken a change in terms of using data. The data that we collect using wearable sensors, by scraping the websites. Um, and when you have a car, it has cameras. Cameras collect data in terms of how the camera is moving, what it is seeing, and so on. So AI has now swung to the other extreme in terms of data. But that is not to say that it doesn't worry about domains, because domain is still very important. Even a smart car, when it mines all this data, it should know where the rules are, where the roads are. It should stop when there is red, and go when there is green, and things like that. So to answer your question, we are using more and more data-driven AI. So that is a change. In the early days, we didn't have so much data. So now we do. And I think eventually domain and data will learn to live together in the most effective way to make progress.
Now, data is a big element. It's described in the book. We have never had more collected than in recent years. What are some of the ways that artificial intelligence is able to, and the use of sensors as well, get data, and then how are we filtering it so that we don't get data that is, as you mentioned, garbage in, garbage out, not of a poor form?
Oh yeah. Oh, that's really a very, very important aspect of AI. Having the right curation for the data, and make sure the data is not corrupted by noise. And also, these days, still most of the existing AI methods that use data use what is in a supervised technique. That means you have to tell the machine that this car is Toyota, this car is Mercedes-Benz, and so forth. You have to provide annotations, right? Sometimes people make mistakes. If you confuse a Camry and Lexus, which is quite possible, look very similar, right? So then, as you say, in computer science, garbage in, garbage out. So we have to be mindful of the data that we use in training the AI systems. That's very important. Yeah.
Now, before we go into some uses of AI, what are some of the difficulties right now in terms of progressing forward? Are there any huge roadblocks to the next steps?
Yeah. Oh, there are a few. I call them the elephants in the AI room. The first one I worry about as the person who develops algorithms and designs AI systems is what we know as domain shift. I get some data, right? Let's say it's a hospital, okay, or a pathology lab, and I train my system using that data. The question is, will it work in the same way with the data collected from another pathology lab? Because every lab uses a slightly different procedure for staining the specimen, for taking pictures, and so forth. This is what we call domain shift. Because the data that comes from a different place may be a little different, in terms of demography, in terms of various other factors. So how do we make sure that AI that works in one place, in one lab, in one setting, works everywhere? So this is a big challenge. For example, if I have a smart car that runs very well in Phoenix, would it work in Mumbai? Or would it work in Hong Kong or UK? They drive the other way in UK, as you know. So domain shift is very important. The second thing is how to protect AI systems. Because AI systems can be hacked if somebody knows how you train your system. They know that this is the training data they're using. They can poison the training data and they can make you learn wrong things. Or they can just hack your system. And it will, for example, in 2013, some Google researchers found that if you give to a trained AI system, just very good in recognizing, let's say, vehicles and school bus and this and that, you give a slightly perturbed input, it may make the school bus look like ostrich. So that's not good. School bus being, called an ostrich. Or it could, a more interesting example is that a lion will be now classified as a pelican. That's not a good idea. You can't. See, the adversarial robustness is very important. Now, again, those of us who have worked with the data in various contexts, statisticians, for example, right? We know that if data is corrupted, it can be it can lead to bad decisions. And we also know outliers can, disturb your estimates and things like that. So these are known in statistics. But the AI models that we are using are very nonlinear, very hierarchical. So they're very good when they do what they do, but they can also be unstable in the sense you can perturb their decision-making ability by, attacking them. So these two are what I consider as, issues that we have to do, because you can't just sell Tesla just in Phoenix, right? I mean, Tesla is selling everywhere. And so a smart car has to be able to operate in all kinds of traffic conditions. So generalizability is a very big issue. And sometimes you may not even know in which domain you are operating. For example, if you tell me, Rama, I want you to design a smart car that works in Phoenix as well as in Mumbai, then I'll go and collect the data in Mumbai. I'll try to figure out, how the traffic pattern is and so forth. So I can then tell the AI system, this is what's going to happen. But if somebody tells me, I want this thing to run in Moon or Mars, I don't have data to do that. That's domain generalization, right? So it's not only just adaptation, it's generalization. So how do you do that? That's still an open problem a lot of us are working on. So one approach we say is let the car, smart car or AI system learn as much as it can by seeing different things, different situations and so forth. So hopefully when it sees something totally new, it won't, have too much of a problem. So that domain generalization. These are both domain adaptation and generalization are still very active research areas. We have been working on domain generalization since 2010, various contexts, and we started the domain generalization sometime around 2018. So these are now established areas of research, and so those two things are important.
Now, before we go into some examples of use of AI, one thing that just came to my mind when you described that is, are you able to, when you're using an AI, see its process and then see where things could have gone wrong? Are there a lot of steps along the way where you can see, okay, this led to this, we have to adjust here?
Very much so. Even while training, when we train the AI system, we do have something called a loss function. So we try to minimize it. That is, what does it mean? I start an AI system with certain, parameters, and then I ask it to predict, what should be the outcome, but I also know what the real outcome should be for that input and so on. I tell the AI machine, no, you're not doing it right. Go and revise your parameters. So this is the basis of what is known as backpropagation algorithm, which is at the core of all deep learning-based AI systems. So as it happens, we can watch how the loss function is behaving, whether it is getting stuck somewhere or it is making progress towards less and less and less as more iterations go. So observing the landscape of the loss function gives great insights into how this AI system is performing and how it is learning. The other thing is we can also probe it. If I make that mistake here, if I have 5% of errors in noise labels. I purposely call 5% of Camry as Lexus. What's going to happen? So I learn all of that, So we can learn, and then we can make sure that it's learning well. But as I said, sometimes you work very, very hard for your midterm, and there's always a quirky question that you may not get at the midterm, right? A very hardworking student, they say, how is that? I worked so hard, particular problem. So sometimes it can happen. An example is the adversarial attacks and so forth. If the AI is not trained for it, it may get into trouble. But then, as we train, we can also give it noisy things, say, make sure you don't get thrown off totally if you get some noisy thing. It's called adversarial training method. So we do that too. We induce noise. We provide label noise. Sometimes we train using poison data purposefully. When I think about it, what comes to mind is, as in India, they always talk about snake charmers, right? People who go and catch cobras and so forth. And of course, you have to be careful when you catch a cobra. It's a deadly snake. And I don't know if it is true or not. When I was growing up, I was always worried about the person. They come with a little pipe and they play and then they catch the cobra. I asked my dad, what happens if the cobra bites the person who is trying to catch? And he said, well, I think this is a family tradition. They do so even as they grow up. They take small amounts of cobra venom to make themselves robust. I don't know if that is true or not, but that made me think, but how do you know what is the right dose? In the process of making you tougher, you might actually injure yourself. So we still don't know. When we train the AI system to be able to be resilient to noise, how much noise should we give to the AI system so it still learns the right things but won't get thrown off when there is noise coming in? That's still a hard problem. So these are all, very good research areas.
That's true. If you gave someone a video and it was just a motion blur with a lot of actual pixelated noise and then the sound was sort of noise as well, after 10 minutes, 5 minutes, an hour, 5 hours, now the person's brain is starting to get damaged. So we're going in the wrong direction there. Right. But some amount of noise is good because then now you're testing for weaknesses or some sort of alternate case.
That's right. Yes, very true.
Now, applying this to categories, one large category is in healthcare and for patients and working alongside doctors per se to figure out issues that people have. Can you give us a couple of examples of how AI is applied there?
Oh, definitely. We discuss a couple of examples in the book. One is the work done by my colleague, Professor Suchi Saria, in computer science at Hopkins, and she actually describes a personal story of one of her relatives was diagnosed with sepsis and didn't have a good outcome. So she's working on using AI to be able to monitor that, detect that, and so on, and provide valuable advice to the doctors. So that is one example. And we have a 5-year effort funded by National Institute of Aging to explore AI and related technologies for healthy aging. We are focusing on detecting and monitoring dementia, Alzheimer's, and so on, using wearable sensors, mounted sensors, and so forth. I think more and more seniors would like to live in their own homes to the extent possible, instead of going to a nursing home and so on. So can we use, continuous evaluation of the data being collected, Fitbit, for example, or Apple Watch, and things like that, and to give an idea of how they are doing, remind them. There are simple things that can help. For example, seniors sometimes forget to take their medications, and it's very important if you're diabetic and and you don't take your medication, or if you have blood pressure, so it can remind, and then it can, keep track of their, pulse rate, heart rate, and all of that stuff. And another interesting thing is wearable sensors that can be useful for fall detection. Seniors have it. I'm kind of getting there myself. I'm 69 years old, and I'm careful when I go down the steps, hold on to rail and things like that. But sometimes when they fall, there may be a hip replacement issues or sometimes even more unpleasant outcomes. So there are wearable sensors being, designed to alert, it's potentially, you may lose your posture or, you may lose your stability and so forth. There's something else we have come to know as part of our NIA, National Institute of Aging grant, which I'm happy to collaborate with two outstanding geriatric physicians at Hopkins, Drs. Jeremy Walston and Dr. Peter Averill. The other thing is, in addition to all of this, somebody has a late stage dementia. Can we, design robots that can kind of actively engage them and give them some minutes or maybe a few hours of really, pleasant life, right? For example, during COVID time, there's a company that we are talking to. At COVID time, they actually had a robot with an iPad will walk into a nursing home, late stage dementia, and bring in music that they were familiar with or establishing Zoom calls with the family and so forth. And that kind of lightened up their life, that moment and so on. So there are all these things. And the most interesting thing we found based on our research now, while we are focusing on dementia patients, Alzheimer's patients, what about the caregivers? It's, if your family takes care of somebody, they're not trained like regular, people in nursing home and so on. So how do we help caregivers in terms of being able to help their loved ones who are having these issues? So that has become another interesting and important issue. While we focus on the patients, in this particular case, since family members take care of their grandparents or their parents and seniors and so on, what kind of advice can we give them based on what they are seeing? And so they have some expert. So what AI will do, Armand, it will be kind of sitting next to you. Okay, of course, everybody says, is AI going to, come and grab my neck? No, it's not. It's going to sit next to you. It's going to look at the data. It's going to continuously and give you some suggestions. Hey, maybe this, maybe that. And then you have to make the decision. So in the context of our thing, the human AI interaction has become very important. Especially in healthcare, we have three things now: the doctor, the patient, and the AI. Before, it was just the doctor and the patient. And as a patient, we trust completely what the doctor says. The doctor has been trained well, the doctor cares about me, and so on. Now, the doctor says, I have an assistant next to me, an AI engine sitting there, and it has looked at all the records, electronic health records, diagnostic images, etc., and it's giving me these things. So I'm going to listen. I'm not going to go exactly what the machine says, but it's a useful thing for me to have. So now you have a triplet. So the patient can ask, hey, doc, yeah, I know you went to a great medical school. I know you know what you're talking about. Suddenly you have this little box sitting there. You call it AI assistant, and then it's telling you something. And so is it a good box? Should I trust? And that's where the can we trust AI thing is important.
Now, one thing you mentioned was that aging and how it can help with aging. It made me think of a related point. I once spoke with Dr. David Sinclair of Harvard Medical on anti-aging. He's an anti-aging individual. Would you view aging as a disease where all the parts can be managed through such items as artificial intelligence, or is it a necessary element?
I think it can be managed. See, there are two things we think about aging. One is mental frailty and physical frailty. Physical frailty because the body is worn out. The knees, are tired. My elbows are tired, shoulders. I can't run when I'm 75 like I used to run when I was 18. That'll be great, but it's the physical frailty, right? Mental frailty is very different, and so so physical frailty you can manage with the therapy, physical therapy, leading an active life, and avoiding certain kinds of food and other things. So I think that can be managed. sometimes the mental frailty, cognitive, impairments and so forth, they happen, and that has to be managed. And I'm not a doctor, so I don't know whether they can be reversed and things like that, but they can be managed, by providing very good surroundings and environments, and making sure they get proper care and so forth. And I think that is where AI will be useful. So there are two aspects as we age. We all age. I mean, it's just a matter of nature, right? I mean, so we all age, but I think can we manage that well so people can spend more time in their own homes and have healthy living, both the cognitive side as well as the physical side, and so technology can help.
It is true. Now, this one, the transition here, I have my wonderful face. We all have a face we work with, and there's a substantial category of analysis happening right now of individuals' faces, recognizing them, possibly creating records, possibly not, using them for AR extension, but also for analysis. What is happening in the field of facial recognition? How concerned should we be as far as trust, like in your title? And what comes to mind in the facial recognition category?
Yeah, I've been working on face recognition since the early 90s. So it's a 30-year work. I think when we first started, we just thought of it as an interesting problem. We used to recognize vehicles and planes and other objects, man-made objects. But face is a natural object, right? Cars don't age like faces do. Okay, we all, so we start, in fact, we like to say, we all are born as a round shape and then slowly became oval shaped. Actually, that is modeled by using a balloon filled with water. Just imagine what happens to it, right? Balloon filled with water in terms of how the shape changes. Of course, in their the 40s and so forth, muscle changes, and when they are 80s, wrinkles. So we have looked at the entire spectrum of things. So it's an interesting natural object recognition problem, right? So it's a deformable object too, right? It's not like a car, right? Yeah, exactly. And then what happened right around 2012, we got this deep learning revolution, and then a lot of data became available and so forth. So you are now able to build robust systems and things like that. Now, where face recognition is going, there are, it still works well in very constrained situations, passport pictures, driver's license. In unconstrained situations, the performance is getting better and so on. I think people are concerned about, facial recognition and so forth. And for example, the 2018 report from MIT pointed out that it may not work well for dark-skinned males and females in a gender classification. It's a classic work. That's because the data set that was used to train the then existing commercial system totally different demographic. So this is again domain shift. Remember I talked to you about domain shift. So if you trained on one kind of faces and then try to apply it from faces of groups from different demography, it won't work because it is not seen. It's like I teach English all the time and suddenly I talk to you in French. You're going to say, what?
Je m'appelle Armin.
So, but it is a serious issue. You cannot introduce a technology that causes concern to even a small number of people in society. A technology has to work well for everyone in the society. So we actually have done some studies on how bias is introduced in face recognition, bias to gender, bias to skin tone, and so on. And we have come up with some remedy for it. If you give me a face recognition system that can probe it, and I say, it has, this much of bias, I can now do this to reduce the bias. So we have papers on this. So we call it adversarial training, knowledge distillation, and so on. These are approaches well known in artificial intelligence. So we can probe, but I like to say an AI algorithm will not lie to you. it will tell you if it is biased. You can find out. You can probe it, and then you can fix it. Humans have biases. Humans may not admit to bias. So, whenever I tell people, when I hear, oh, AI has bias, and I said, yeah, humans have biases too, but it's very hard to probe a human and find out. Whereas AI, you can probe. There is a technique known as mutual information, mine it is called, mutual information neural estimation. It basically says how the outcome of an AI system depends on its covariates. In face recognition, for example, as you said, gender may be an issue, skin tone may be an issue, age may be an issue, and so on. But I can probe because it's an algorithm. For an algorithm, Armin, you give the same input, it will give you the same output. It won't give you, right? It's a code, right? As you know. But so I think we are concerned, but we can remedy it. And what we also find there is a trade-off between so-called bias and performance. So we have to also look into that. So what we do, we take the best performing system and we reduce its bias. So I tell people, every technology has its issues. Always something, right? We all like, I don't know, candy, but candy is not good for you for a certain reason. Not a great example, but I'm just saying it's not a technology. Eating candy is not a technology, but there are always issues with anything we do. So we have to be able to manage the positives and the negatives. Having said that, face is not just useful for recognition. We are working on a project with a critical care doctor at Hopkins, facial phenotyping for monitoring stroke victims. When people are brought into emergency with issues of symptoms of stroke and so on, we don't interfere with the process. We let the doctors stabilize everything. The next day, we try to capture face images with their permission, with their consent, and then see if there is anything that we can, likewise, Parkinson's, facial, phenotyping, autism in young children. So we are looking at these problems right now. So whenever I think of facial analysis, recognition is one component. It's useful to some entities. But in the medicine space, we are not trying to recognize a person because we know who is being brought in. We don't have to worry about that. But we worry about, is there anything that is indicated in the face? Because my collaborator, Dr. Robert David Stevens, says, whenever I enter a room with a patient, I look at the face, I say something is not right. See? So can AI catch it? I think that is what we are very interested in.
You bring up two great points that came to mind here. One of them was on how it's interesting. You made me think of the bias in AI. It will be called biased, even though you can see it, and it's not really biased because you can examine the code, whereas the individual who may have bias, but you can't see it, you'll say, oh, it's less biased. It's always inverted in life, like the person who's actually comes out loud in front of an audience and says a bunch of things. Oh, that person is cold and rude. Maybe they're actually nicer than the person who's not saying anything behind the scenes, but has things in their mind.
Yeah. Good point.
It's inverted. And then the second item you reminded me of was you mentioned stroke and AI possibly telling you about stroke. I know somebody who had a stroke and then had surgery on one side of their brain, and then just a few weeks ago they're starting to feel a little bit back. So possibly AI would be useful to give them or people like them a sense of this is how much you should probably worry of something happening again in the next year, 2 years. Yeah. Whereas right now it's more like uncertain, which makes them nervous.
Yeah. My wild dream in that is by just analyzing facial expression, how there is a temporary issue that has facial deformation and then it goes away a little bit after a while and so forth. But stroke may have more, may create more permanent damage. Is there a way I can localize what is based on what is happening, where it is happening in the face, that which part of the brain is having issues, the inverse mapping? I think because then we don't have to, we'll have some idea. Of course, there are more elaborate tests that will be done to pinpoint, where the real problem is in terms of which part of the brain is being affected. But this may be a very preliminary, rough idea. I mean that my collaborator thinks is a game changer, because you know why? It's easy to capture this, right? Once the patient is stabilized, the patient gives consent, we can take picture using iPhone, and then we can analyze it. Right? So you don't have to, go through very extensive things at that time. But I think the idea here is not to interfere with what's happening there. The idea here is to augment and provide additional cues. And so this is research, so we don't know yet, but my collaborator is very excited, and I'm very happy to be working with him on this. So I've done a lot of work on facial expression recognition, and the micro expressions are probably a little harder, and so on. But there is some, potential in terms, because as they say, face is a window to your soul or something like that. I've heard somewhere, right? So face does convey, face does convey a lot of things, yeah.
This is very interesting what you're saying, because the individual that I just described with some strokes before, when they had issues at some time, like they would smile and only they would half smile because half of their mouth would kind of droop. Things like that would say a lot.
Yeah, we can track it by looking at fiducial points. We can get about 68 points on your face, and then we can see how they are moving. And if they're moving in a coherent way, or there is some local deformation in the points, they're moving in their own way, and so on. So those are things we are looking at.
I think it will be very informative. My call on that is I think that category will be very informative, because just from what you said, for some reason about it, it really made sense to me that that'll be a great way to figure out things without having to go right into the brain.
Yeah.
Interesting. Now, I'm going to share that, by the way, with that individual. That'll be good. A completely alternate category is a very popular one, autonomous driving vehicles, AI usage for that, which is currently getting so much data from all the electric vehicles that are sending into their systems. How far away are we from constant use of that? Do we change at some point to where our freeway is mostly cars that are speaking to each other? Where are we at in that?
Oh, that's a great question, because that's what people are all talking about. What if half the cars are totally automated cars and the other half are Model T? Of course, we don't have Model T anymore. How is that going to work out? It's not like one day we decided, okay, stop non-automatic things. Everybody has to do automatic things. That's not happening. It's going to be a progression, right? I think I would like to make a couple of points. I've been working on the unmanned ground vehicle problem since the early 90s. And some of my senior colleagues have been doing this since the mid-80s. It used to be called Autonomous Land Vehicle Project by DARPA in the mid-80s. In the 90s, it became unmanned ground vehicle. We used to instrument sensors and so on. It was more a defense application to see if we can send a platoon of cars, do surveillance and things like that. Now, autonomous car is a great application, successful application of computer vision technologies, because cameras are in the car. They are the ones detecting that there are cars in adjacent lanes. Or they tell you whether you're going to hit the car in front of you, it gives you an alarm and so forth. Even less expensive entry-level cars have these things. So are we going to have a fully autonomous car? Probably we will. Some people thought by now it should be there, but it's not there yet, although you can see successful refinements from Tesla. If you're one of those guys who signed up for automatic upgrading of software, you see more and more of that. And I think for all of that to work, as you say, cars should be able to talk to each other, so they know where your car should know where all the other cars are, and so forth, and they should be able to talk to you. Networking is very important. Real-time, issues with networking and processing of data. So we've seen the early 90s, we couldn't even process data real-time, and the car would be driving at like 2 miles an hour because we didn't have the computers to be able to process video. Now we do. So there are a lot of issues involved here, right? Networking possibility and people willing to let the car drive them to work. Not all of us are willing to do that. There's always, interestingly enough, somebody asked, there was a question: would you like planes to fly automatically, just take off, fly, and land? Do we need pilots? I don't know which country it is. I think maybe Germany. 60% of the people said, "Yeah, we're fine with it." But when I think about it, I like to see this gray-haired pilot walk into my United cockpit, especially when it is flying over the ocean. I feel comfortable, right? So same issue with a lot of people. And some people really like driving. So what I'm saying is not just about technology. It's about how society is willing to accept this en masse, right? That's what is going to decide. Having said that, even what we have now and the continuous improvements we are making with respect to improving the safety, all the things I mentioned, if it is night, if it is raining, your car will still tell you there is a car next to you, don't change lanes. It gives these red triangles on your, side view mirrors, and it's very comforting because it is now, it's dark. And so on. And there are many other features. When I test drove Infinity a few years ago, if I try to change lanes without giving turn signal, it will pull me back to my lane. I had fun with it on the freeway. But that's a good thing, right? People sometimes just change lanes without giving the turn signal. So all of these things are still very good. So what I'm saying is, let's not assume that unless everything is totally automated and everybody has automated, that's the only goal. No, I think we can still have the mix, but we are improving the safety features in the car using technology. And I think that still will reduce the number of accidents and so on. I think there's some car I've been told that it can have a breath analyzer. If you drink too much, it will say, "I'm sorry, I can't start the car for you. Stay here for a while. I'll call a friend." That's a great thing, Anyway, so yes, I think, as you said, for the whole thing to be totally automated, everything has to kind of sign up for it. But till that happens, I think we are still steadily making progress, and that's very good.
Cars have to have some sort of vision in them. A long time ago, I knew a person who their goal in life from early on was to solve what he called the computer or robot vision problem. Would you say that, is it like a thing that can be solved? And then how close is computer or robot vision to our vision at this time? Or is it past us at this point?
Well, it can do well prescribed tasks. For example, robots are used in automobile industry, right, for a lot of things and so on. If you have a very well understood sequence of steps, an algorithm is such that, right, a computer, you have to have a well defined set of things, what to expect, and the domain, the inputs, outputs. Then the robot doesn't take coffee breaks. It doesn't go to bathrooms and so on. So it just works and works and works. So that's good. But the big difference between humans and robots, common sense reasoning. Okay. Once you have seen a McDonald's in the United States, you don't have to be trained to recognize it in Paris. I mean, maybe the menu is in French, but I'm sure they have English translation for it. You don't have to worry about where it is and so forth. Immediately you make all their things that you like to buy and try and so forth. See. And there are many other things. And humans are better at dealing with surprises. Okay, robots have, AI has problems with surprises unless it has been trained. Although domain generalization is a way to make it work in environment it has not seen, it's still not there. It's still not deployable. So that is the big difference. People ask me, when is robot is going to come and take over, the iRobot movie thing? I said, nah. Humans, a 2-year-old probably has better common sense reasoning skills than the best robot we have right now. Okay, I mean, they're thinking. In fact, interestingly, if you read the seminal paper by Alan Turing, how to build intelligent machines, the last paragraph says we probably have to teach AI machines like how children learn. Children learn in very interesting ways. You have to just show them a couple of examples. And if you have a 2-year-old and say, hey, this is a cup, And then, oh, that's a cup. That's a cup. In fact, if you ask a 3-year-old, 2-year-old, show a tree, and where is tree's tummy? The kid will show somewhere in the bottom, one third, that is tree's tummy. And how did it, generalization, the common sense. Okay, tummy is where it's not at the top of the head. Right? So, to me, that's what separates. But can a bunch of robots work together and things, better manufacturing wise, other things? And in fact, if you see, autopilot is very, very normal in long flights. The pilot will take off and then they set it up with the coordinates and the computers are monitoring everything. And, so they do that. Of course, there's always an override option and landing again the human. Because there are surprises that can happen in takeoff and landing, and so humans they're trained, they're continuously trained. So it's a great vision to have, robots, human thingies, but common sense reasoning is still a big hurdle to overcome. I think people are working on it. Eventually, a robot may come and just, that's the whole point about the Turing test, right? Behind the screen. And so on. So it's a goal we are working towards. But as in the autonomous thing, our goal is to make it fully autonomous. But to get there, we have to solve so many things, and they are extremely useful. Likewise, our goal is to build a robot that reasons like a human being. Even if we don't get there, the process of getting there will create a better robot, caregiving robot. There are people are thinking of designing robots that will help an elderly person to get up from the chair and hold hands and walk and provide company and chat and this and that. So there's so many, things are possible. So I think, we're making progress.
My last pair of questions here is, who are some key figures in the field or who have influenced you? And after that, where can people find your material? But first, who are some key figures in the field who have influenced you or influenced the field?
Yeah, I'm probably one of the most luckiest persons in my field. My teachers at Purdue were pioneers, and I mentioned them in my acknowledgement. Professor Kingston Fukunaga, my advisor, Cashier, Tom Wang, Dax Lansky. And then I also had the opportunity to be advised by Professor Asriel Rosenfeld, who is one of the founding fathers of computer vision. Amazingly brilliant. All of these people are brilliant people. I think they figured something that they probably figured this kid needs help. That's what I always say. They took me under their wings, and I watched them, how they work, how they interact with other students. And I feel, I probably, if I talk like this, I might get a little emotional because my teachers, right, have been fantastic. And then, most of us, when we start teaching, we think we are always teaching, but very soon we realize our students teach us. That's the beauty of it. I have supervised 116 doctoral dissertations, and every one of them is a gem. And my God, they taught me so much. In the early days, the age between me and my first PhD student, the difference was 4 years. Then you're not really like a professor-student. You're like, friends. Now, students come to me when they're 22, when I'm 69. There's a big gap. They always say, sir. And at some point, I got a PhD student who was born after I got my PhD. I said, that's a milestone. So my students also, I'm very grateful to them. Right? They have learned a lot. They inspire me. They work hard. They think of new things. They're not afraid. So for me, I'm lucky. I put myself between the best teachers and the best students. Right? So to me, I can't, this is what it is. My life has been blessed. So I'm very, very happy about that. Of course, the family help is extremely important and so on. So what was your second question you asked?
And the second one is, where do you showcase your work? Where can people look at your material?
Yeah.
And what would you want them to see of that?
Oh, yeah. And as you know, you showed the most recent book that Johns Hopkins University has brought it. I think I hope people buy and read that book. The goal here was to remove fears and misconceptions about AI and assure people it's a technology that's worth investing, worth developing, worth understanding, and at the same time, if it is not functioning well, fix it and make it better. All technologies, they developed like that. So that was the original goal for writing this, and I was extremely fortunate to have my co-author work with me and the Hopkins University Press people guiding me throughout that. We publish papers in premier computer vision conferences, machine learning conferences, AI conferences, so that's where people should look. And also there is Google Scholar, as you know. If you put my name, it will list every paper I ever wrote. There are about 850 or 900 papers, so it's all there, and people can get them from various places where they got published. And I also have written about 8 or 9 other books and edited books and so forth. So these days it's very easy to find what people have written. You just have to go to Google and then it spills out everything. I tell my students, when I was a student in the late 70s, every Friday afternoon I'll take a bag of coins, go to the library, take things, and use the Xerox machine, and that's how I didn't have iPad then. I didn't have Google then, so that was a hard way to get access to various materials. But now you just go to Google Scholar and put my name, you know what I have written, and you can get them, most of them for free actually. Not the books, but the papers are, yeah.
I have to add in this one because you just reminded me of it, saying that because yesterday the power went out, and then I was able to do more of interesting things when the power was out than usually when it's on. Are we disadvantaged in 2022 when we have so much ability versus times where it's more difficult, and so necessity kicks in our human instinct and we have to do more?
Oh, that's a great observation. I think about it. I tell my students, sometimes you just have to shut everything up and take a walk. And the best ideas come when you take a walk. And in fact, the thing about doing PhD, it's not a programmed thing. When you do BS, when you do MS, you take classes, you have to do well, you get grades, and you do some research with professors. Yeah, that's all good. PhD, there's no guarantee because you have to come up with something that's new. New is within quotes. So you have to be alert. You have to be open to the ideas, right? So you have to be aware all the time. But if you immerse yourself all the time with looking at the monitors and Google and this and this and that, that is taking all your attention. So sometimes it's better to, just drop all of this half an hour a day, or just take a walk and think about what you're doing, and then the ideas come. And that's what I tell my students. Be aware. Keep your antenna up. When that even small ideas can sometimes grow into something very big. So to respond to what you just said, I totally agree. We should not just be so consumed with what's on our iPad and laptop and so forth. We should be, very few students these days read books, they tell me, and it shocks me. They say, nobody reads books these days. So I said, no. Stuart Russell and Peter Norvig book, you should read the book if you want to know what AI is all about. How can you not do that, right? So, this is from generation to generation. Then it's always, the older generation thinks it did things better than the next one, which is not always true. Yeah.
I think this message of focus is very important and can be a huge advantage for, let's say, the younger generation if they're able to apply it in this current time.
Yeah.
Dr. Rama Chellappa, with your book and joining on this episode, I would like to thank you for having taken part, provided a wealth of knowledge on artificial intelligence and its uses, difficulties, implementation, and where it may go.
Thank you, Arvind, for having me on your show. I really enjoyed our conversation. Thank you.
Glad to. And we are out.